Hey everybody, this is Dr. Jacobs. Welcome to our lecture on complex experimental designs. So this week we have some unit learning objectives. Remember, these are the things that I want you to be able to do by the end of the unit. So if you're going through and making your study guide each week, these are the ones that should be guiding that work. All right, first I want you to be able to define factorial design and discuss reasons a researcher would use this design. I want you to be able to describe the information provided by main effects and interaction effects in a factorial design. I want you to be able to discuss the role of simple main effects in interpreting interactions. I want you to be able to compare the assignment of participants in an independent group design, a repeated measures design, and a mixed factorial design. All right, let's get started. So factorial designs, this is the type of design that we use when we want to conduct a study that has more than one independent variable. Remember, we use the symbol IV to represent independent variables. So typically there is a general format. Sometimes you might have heard someone say, hey, I'm going to do a 2x2 design or a 2x3x4 design. And you're like, what the heck does that mean? So the general format for this is if what you do is you put the number of levels of your first independent variable, you multiply, then you put times the number of levels of your second independent variable, and you times that by the number of levels of your third independent variable. So for example, if I had 3 independent variables, my first independent variable had 2 levels to it. My second independent variable also had 2 levels to it. And let's say my third independent variable was sneaky and had 3 levels to it. That would be a 2x2x3 design. And so when you hear that, it's not as scary as it sounds. There is a method to it. And we remember that we use the symbol lowercase italicized k to represent the number of levels to an independent variable. And sometimes students will get that confused. And actually, that's something I want you to know too. So that would be another unit learning objective that would be good for you to have, is to be able to distinguish between the levels of an independent variable and the number of independent variables, because they're 2 separate things. So go ahead and add that on your list for your study guide this week. So when we're talking about the levels of an independent variable, we're talking about the number of groups we're comparing. So for example, if we say, let's examine if people who drink coffee are happier than people who don't drink coffee. Well, we have one independent variable, that's going to be your coffee status, and we have 2 levels to that independent variable. Either you drink coffee or you don't, okay? And so that would be one independent variable with 2 levels. Well, some of these studies, you can actually do more than one independent variable. So for example, if we wanted to examine the sleep habits of people in high school, and let's say that we have 3 groups, we're looking at gender identity, we'll look at people who identify as men, people who identify as women, and people who identify as non-binary. Yes, there are other gender identities, but let's just say that's what we're studying. And then we also wanted to examine the differences in sleep among the 4 grade levels in high school. So we have 2 independent variables. We have gender identity, which has 3 levels to it: identifies as male, identifies as female, identifies as non-binary. And then we have grade levels, which is a second independent variable that has 4 levels to it: 9th grade, 10th grade, 11th grade, and 12th grade. So in that example, we would have a 2x4 factorial design. So an example, if we have a 2x2 factorial design, that means we have 2 independent variables, each with 2 levels to them. Okay, so interpretation of factorial designs. When we're doing these factorial designs, we have things that we call main effects and interaction effects. And so when we're examining factorial designs, we're typically using an ANOVA to analyze the differences. So in the previous example that we gave with the examining sleep habits of people and checking one independent variable based on gender identity and one based on high school grade level, we would find a main effect for each of the individual independent variables on their own. So gender identity, we would examine to see if there's significant differences on sleep habits of people between the 3 different gender identities that we listed. We'd also have another main effect for high school grade level, and there we would examine if there's significant differences in the sleep habits of 9th, 10th, 11th, and 12th graders. We also have something called the interaction effect, and this is when the effect of one independent variable depends on a level of another one. So in this case, what we actually do, if we're using that previous example, we would be comparing all of the different possible combinations of groups. So we would compare people who identify as, so ninth graders who identify as males, and we compare that to ninth graders who identify as females, ninth graders who identify as non-binary, and keep comparing all these 10th graders who identify as male, 10th graders who identify as female, 10th graders who identify as non-binary, 11th graders who identify as male, 11th graders who identify as female, 11th graders who identify as non-binary, 12th graders who identify as male, 12th graders who identify as female, and 12th graders who identify as non-binary. And so when we did that, and I think my fingers were wrong when I was doing the fingers, but in the interaction effect, when we're doing that type of ANOVA, a factorial ANOVA, we're going to be comparing each of those individual groups to see if there's a significant difference somewhere in there. So again, we're going to use an analysis of variance, or an ANOVA, to assess the statistical significance of main and interaction effects. Specifically, we'll be using a factorial ANOVA. So if we have two independent variables and we're doing a factorial ANOVA, we'll actually have three research hypotheses, one for each of the main effects and one for the interaction effect. So simple main effects then just examine the mean differences at each level of the independent variable. So if we're going back to that example that we just made up off the top of our heads, we would examine the difference between the sleep habits of people who identify as male, female, and non-binary. That's one simple main effect we'd study. Another simple main effect that we'd examine is there a significant difference in the sleep habits of people who are 9th, 10th, 11th versus 12th graders. So there's different types of research design that we can use. Here it's color coded. So if you have visual impairment of some kind or have color blindness, it might be difficult to see this. So I'll try to articulate it as well. But when we use a between group design, we have different participants in each of the conditions. So if we are able to examine the color coding that I have here, we have a different participants that get sleep and street tacos. Say like we're trying to see if there's significant difference in the amount of happiness someone has based on if they have sleep, no sleep, street tacos, or no street tacos. So in this between group design for this factorial ANOVA, we have 10 participants that get sleep and street tacos. I'm just saying, it's science, right? And then we have 10 different participants that get sleep but no street tacos. And then we have the no sleep condition, but they get street tacos. And then we have the no sleep and no street tacos condition. And so to do a between group design, or sometimes you hear it referred to as independent groups design or between subjects design, they're all the same thing. We would need 40 participants so that we could have each of the different conditions have different participants in it. Now, if we use a repeated measures design, this is when we'd have the same participants in every single condition. So for example, one day we'd let our 10 participants have sleep and street tacos. One day we'd let our 10 participants get sleep and no street tacos. Then one day we'd let our 10 same participants get no sleep and get street tacos. And then in the last condition, we would allow the same 10 participants get no sleep and no street tacos, remembering with the information that we learned about counterbalancing earlier in the semester about making sure that there's not ordered effects and carryover from the different conditions. So the last one that we have in this relatively short unit was the mixed factorial design. And this is where you use both independent groups and repeated measures design within the same study. All right, so with the mixed factorial design, this is where we use both independent groups and repeated measures design. So in here we see that we use a within group design or repeated measure design for street tacos versus no street tacos. So we see that 10 participants in the sleep condition get street tacos one time, and then those same 10 participants get no street tacos in the other time. Then we see between the sleep and no sleep conditions that we're actually using independent group design, which means we have different participants who receive sleep than the ones that don't receive sleep. And so for this type of mixed factorial design, we would only need 20 total participants for it. So we'd have the 10 participants in the sleep condition, who will get street tacos at one point, and those same 10 people will get no street tacos at the other. And then we have a different 10 participants that are in the no sleep condition. They get street tacos one day and no street tacos a different. So that is all we have for this week. It was a really short chapter. We're moving right along in the semester. We're learning almost everything that we need to be successful for the end of the year. And I'm really excited. Let me know if you have any questions.